Welcome back, everybody. And as promised, I've got another question here that pops up quite regularly that I figured best answered in video. Now, the question here is, if we're doing so much work and we're doing DXF files and doing our layout for flat patterns and for form blocks using the laser, why don't we use the laser to cut out the form blocks and cut out the flat patterns while we're at it? And it's a good question, and it's really, there's a couple answers to it. So I'll tackle flat patterns first because they're aluminum. And the primary reason why you wouldn't use any laser to cut out the parts is because the laser uses heat when it cuts. And for an aircraft part to be cut out with heat, whether it's with plasma, whether it's with oxyacetylene, whether it's with laser, you create a heat-affected zone around the cut that changes the mechanical properties of the material. So it's hard to gauge how far into the material that amount goes. It's caused by the heating and cooling of the cutting process using those methods. And it would be far too much work to try and determine where the mechanical properties go back to where they're supposed to be for that. So basically you can't use those methods to cut a part that's going to be structural on an aircraft because it changes the mechanical properties in the heat affected zone around the cut. So that's the first part of the question for flat patterns. Second part is that our laser here is a CO2 laser, and CO2 lasers, although I've heard some people cutting very thin aluminums and maybe copper and brass, I'm not sure. They're not intended for metals, and as far as I'm aware, it causes damage to the machine. So it's not ideal for aircraft parts, and it's not ideal for metals in general. It's basically good for everything else, so non-metallic materials. If you wanted to cut metals with a laser and they weren't aircraft parts, you'd be using a fiber laser to cut metal, steel, anything really. But that's not what we have here. Now the form blocks, the wood that we use is approximately 3/4 inch medium density fiberboard for the form blocks. And that can be cut on the laser. It's pushing it for this machine. I think it's actually a bit above capacity. I've cut the material in a 2-inch circle, maximum power and slowest feed on this machine, and it will cut it. There's a bit of a kerf, which is the angle of the cut as the energy dissipates through the material. But in that 2-inch circle, I also blew the breaker on the machine. So it's over the capacity. It leaves, on MDF, it leaves a dirty finish, so it'd have to be cleaned anyway. But the primary reason is because almost everything that we cut out here, it might, if we're doing a form block, first of all, it's going to be a compound curve, because if we had a straight bend, we'd just put it in the brake and bend it that way. Sheet metal box pan brake is what we use for most of that stuff here. But if we're using a form block, we're going to have a compound curve, which means that it curves, you have to bend 90 degrees, say, and then also around a radius or a shape. So the form blocks have a lot of shape to them, and it's very, very rare that we actually have a compound curve, say a channel or angle section that we have to form using a form block that is 90 degrees. In almost every case, the flange angle on those bends is other than 90 degrees. And this machine here, and as far as I'm aware, every laser will only cut 90-degree bends. My assumption is because of focus, and changing the angle of the cutting head would change focus. And if somebody's heard of one, that would be awesome. But ultimately what you need for that is a 4 or 5 axis CNC router, which would be excellent. We don't have one here. It would be nice to have, but for the amount that we're producing, it's really not that difficult for me to come in here and lay them out using the laser so we have our accuracy, and then hand cut and file and shape them to get a very, very true finish on them and produce the parts that we need to here. So that answers that. That's why we don't use the laser for production of flat patterns for the Typhoon project, and we don't use it for the form blocks, although we use it for other interesting things around the shop, like you might have seen things like this. And that's it's a nice cutaway view that we just did onto a piece of plywood, and we did that for visitors, people that are coming to the shop. And if we're trying to explain basically, well, we've got a fixture or an assembly that's in progress, we can point to areas on pictures. We've got another one here just across that I've shown you a couple times before. It's the cockpit tube structure. And it helps people visualize the work that we're doing in different fixtures or the parts that we're creating. We can point to where they are on the aircraft, so it helps quite a bit in that regard. So that's that, guys. That's why we're not using the laser. Now, I guess a follow-on or an additional question that follows into that kind of category is why we're doing so much manual work on this and not using more CNC. And ultimately, it comes down to the fact that CNC is excellent for production. You can produce a lot of parts from one file and reduce man hours that way. But it does take a lot of time to set those up, and you need the equipment. So the equipment is worth it if you have a product that needs that type of work. And in almost every case, if somebody's doing work like we're doing here, it's basically done in the same manner as prototyping would be done. And it's when you're expecting to make one or two pieces, it's easier to produce handmade parts and more cost effective to produce handmade parts than it is to go out and invest in significant CNC machinery and software programs to run that machinery and develop your designs and produce one part using a computer-controlled machine. So we're very manual here, although CNC is being used wherever we can possibly use it to save time as well. So there's a certain place for it in the restoration, in the rebuild, and that's where we're using it. So thank you very much for the questions. Keep them coming, guys, and I'll keep the answers coming. Merry Christmas to everybody. Take care.